Hello, so today we will be solving this question. LeetCode 2331, evaluate a Boolean binary tree. So I'm not going to read all of this, so I'll just explain the question. So what basically they are giving is they will give us a binary tree, and this binary tree is like a special type of binary tree in which the tree will have like one of the nodes of the tree will either have 0 children or 2 children. So that type of binary tree, I forgot actually its name. So what they have given is they have given us a Boolean expression. So if you are from like CS background, you know about Boolean expression, which is basically just some logic gates applied to Boolean values. So Boolean is basically true or false, and or not are basically the logic gates. So they have just given that Boolean expression in this form of Boolean tree, in this form of binary tree. So what you have to do is we have to first get the expression and evaluate it and return whatever the result of that expression is. And they have given us the rules. So basically what is this here is whatever the child nodes are, the child nodes will be like value will be false or true. So child nodes are basically the values that needs to be evaluated, and their parent is basically the operation that will be performed on them. So let me just explain how we are going to solve this. Okay, so I have just taken the same example that you. So what we have to do here is we have to basically first convert this binary tree into a Boolean expression. So if you look at this question, what we see is first we can evaluate these children and put the result here, and then evaluate this level and put the result here. So basically we have to find a way to travel this tree in such a way that we can get this expression. So for this the expression is basically like this. So this is what the expression is. So this true is this, the or is the parent node, and this is the other expression. So if you look at the expression we have found, you can just basically do this using a depth first search algorithm. So if you don't know like what is depth first search or about the trees, we will not be able to solve this. Okay, so the depth first search, basically what we are going to do is like there are different ways to do the DFS, like pre-order, in order, and post order. So pre-order basically means we visit the root node first and then visit the other nodes. In order, we visit the left node first, then the root node, and then the right node. And in the post order, we first visit the left node, then the right node, and then the parent node. So if you look at this expression, you can see that we should use a post order DFS here. So what I mean by that is for this what we will do is we will first visit this left, then we will visit this right, and recursively now this is also a subtree. So for this we will visit this left, we will visit this right. We will just basically for the parent node we will just do this operation on both of them and return the result. Now the result will be here, and this will be left and this will be right, and in the post order this will be the parent node. So we'll be basically visiting the root node or the parent node at the last. So that's what the post order is. So let me just code this. Okay, so we'll be using a simple recursion for this. Now what should be the base case for this? So what can be added as a base case here, for because for recursion we need a way to return the value. So what we can do here is basically, because there will always be, so for any parent there will always be a left child or right child, and if so the base case we can put here is basically the leaf node. So if we found a leaf node, then we can just return whatever the value of the leaf node is. So let's write that base case here. Now so basically here what they are given is 0 will be false and 1 will be true. So we have to return boolean value, so we'll just convert that to boolean. So what this will do is if it is 1, it will return true, and If it's any other value, it will just return simply false. So now that this is taken care of, now we can do the DFS part. So the DFS, what we have to do is we have to first visit the left nodes. We'll just, and then we have to visit the right node. Now, after evaluating both of these, we have to check like what operation should be performed on them. So they have also given like if it is 2, we can do or, and if it is 3, we can do and. So let's check that. And that's it, I guess. I think we have to return some base value, so we'll just return false here. Let's try running this. Okay, so this works and this is also pretty efficient. Thank you.